Alright, so morning, today's lesson and Friday's lesson are going to focus heavily on exponential and logarithmic formulae. I might actually try to do Friday's lesson today as well, so if you want to go straight from one lesson to the other, you can do that. Let's see how we go. So the first thing I want you to do is a bit of revision, explain how you find vertical asymptotes. Don't need you to find one, just explain the process. Okay, so exponentials. We've worked with exponentials before, but not specifically in depth. So exponentials are made of two parts, a base and an exponent. So here we have 2 to the power of 3, which translates to 2 times 2 times 2, so 2 multiplied by itself 3 times, which is 8. Okay, so relatively simple, but the issues arise when we are given something like 8 equals 2 to the power of x, and we need to find x. And obviously with this small number, we're able to work it out in our heads, but something a little bit more complex we need to process. Okay, so we've spoken before about how every operation has an inverse. The inverse of addition is subtraction, the inverse of multiplication is division, the inverse of squaring is square root, and the inverse of an exponent is a logarithm. Okay? So, if we are given a equation like 2 to the power of question mark equals 8, we then need to use a log to find out what that is. Okay, so you'll see here in this little formula here how log base 2 of 8 equals 3 because 2 to the power of 3 equals 8. So you should be able to see how these three numbers then match into a log. And this is simply a way of undoing an exponent. That's all logs are, logarithmics. Okay, so this is basically, this here is asking how many times do I need to multiply 2 by itself to get 8? And the answer is 3. So if this was 248 or something, how many times do I have to multiply 2 by itself to get 248? Okay, so I would recommend you copy down this diagram because this is a really good way of explaining it. Okay, so I've used a phone because I've been using my phone calculator to do these calculations. But if you're using a calculator, you will have 2 buttons, an ln and a log. Okay, so the log is log 10, log base 10, and the ln is a natural log, so log base e. We will be touching on that a little bit later, but we'll focus on the log 10 because it actually says log and it's probably easier for you guys to work with that just now. So log 10 is asking how many times does 10 need to be multiplied by itself to get x. Yeah, that's what it's asking. So you might notice log 10 and log 2, they're not the same thing. So that's the next thing we need to deal with. Alright? So your calculator does not have a log 2. It doesn't have a log 3 or log 4 or log 8 or anything like that. It only has a log 10 and a log e. So we need to work out a way of finding a log 2 on our calculator. Now it's quite lucky that if we have a log 10, we can divide the log 10 of x by the log 10 of a in order to get our log a of x. So if we have log 2 of 8, which is what we were dealing with before, so how many times does 2 need to be multiplied by itself to get 8? Okay, so how many times does 10 need to be multiplied by itself to get 8? Bit of a weird question, but let's move on. And how many times does 10 need to be multiplied by itself to get 2? So log 10 of 8 is 0.9, and the log 10 of 2 is 0.3. 0.9 divided by 0.3 is 3. So here we get our answer that to get 8, we multiply 2 by itself 3 times. Okay, now this is, I'm pretty sure this is all new to you guys, so feel free to pause the video, go back and check these things. But this is a worked example here. Okay, so what I want you to do is, using this process here, I want you to find these 5 exponents, and the answers are in the notes on the PowerPoint. So how many times do you need to multiply 10 by itself to get 1,000? That's what's asking. So A will be how many times you have to multiply 10 by itself to get 1,000. How many times do you have to multiply 9 by itself to get 81? How many times do you need to multiply 3 by itself to get 59,049? How many times do you need to multiply 0.5 by itself to get 0.3125, etc., etc., etc. Okay? And you can get these answers by using this process here. This process here. Okay, so use your logs. All right. So for the write that essay and the reading task, this is a bit of a big task, but it ties in really well to what we did last week. So what I want you to do is I want you to open this link and giving it a bit of time. Here we go. This goes through. You don't really need to read the actual formula. You can kind of skim it. Goes through the introduction of rabbits in Australia. And I hope this looks familiar based on what we did last week. And what we're doing is we are looking at some of the efforts that Australia has made to kill off the rabbits in the country. And my question for you is this. I want you to write a paragraph explaining how exponential growth has affected Australia's ability to control the population of rabbits. Okay? So you don't need to read the whole thing, skim it, have a look at the graphs, get an idea for it. But how has exponential growth affected our ability to control the rabbit population? Alright, so have a go at that, have a go at these 5 questions here, and send me an email with what you've been able to do.